Hi, I'm Tanvir Kaur.
I'm Jack Feenstra.
I'm Kathleen Martinus.
I'm Duncan Clipp.
And we're Team 25, and this is our Python group project.
So this is our code. It first starts out by asking the user for a file name, and then it checks the ending of it. If it is a .png file, it will move on. If it is not, it will print an error and end the code.
So the first function is the grayscale function. It reads every pixel of the picture along the x and y axis from each array in the original image. It multiplies each pixel by a constant in each array, and then adds them together and puts them into a single array in the grayscale array. And then it returns the grayscale array and saves it.
For the noise smoothing function, there are 3 separate functions inside the function, and there's arguments to define the image and what filter type it should be. And the convolution function has kernels that are essentially matrices smaller than the original image in height and width. And there's also a for loop within that function that loops every pixel in the image and returns a new array, which eventually goes into the other functions, which are the filters. And it shows the image of the blurred image and it saves it as a new image.
And then for the Sobel part, I used a modified convolution function from above that does the same thing. And for the Sobel in the x direction, we convolved the previous array with the Sobel operator in the x direction, and then did the exact same thing with Sobel y in the y direction using a different Sobel operator. And then for the gradient function, you take the square root of the derivative of Sobel x squared plus the derivative of Sobel y squared, and that creates the gradient image.
And then finally, for the threshold function, it takes all the values that were computed in the previous gradient function, and it inverts the colors and then applies a threshold to better define the edges. So it does this by first calculating what the average of the array from the gradient threshold is, from the gradient function, and it multiplies this by 2. So this is the threshold value that the function will use. And then from there, the code sets all of the values above that threshold value equal to 255, and then all the other values equal to 0. And so this is what inverts the image and then also makes the edges easier to detect. And then finally, after that, it saves the image as a .png file, and yeah.
All right, so for the code, I'll first input a error. So let's do coins.png. And I didn't run it. Here we go. My bad. Coins.png. And it errors. Now let's do it correctly. It'll run. It does take a second, but it's not as bad as what we've heard from other groups. So. And there it is. Then let's do it one more time with the Purdue Arch. Purdue Arch.png, run. This one does take a little bit longer just because there are more pixels, but it's, again, not too bad. And there it is. All right. Thanks for watching.